So the purpose of this video is to demonstrate the use of the TI-Nspire calculator in geometry in order to solve both a system of linear equations and also a quadratic equation. So if we look over here on the right hand side, we've got a couple of examples. Here you can see, based on the markings, we have a parallelogram ABCD with the diagonals marked. We should know from the properties of a parallelogram that the diagonals bisect each other, and so this would allow us to set up the equation x plus y is equal to 2x minus 3. The second equation we'd be able to set up would be 2x equal to 5y. As you can see, we have a system of two equations with two unknowns, the unknowns being x and y. We can of course solve this using algebra, but the purpose of this is to demonstrate the use of the calculator. So come across to your calculator. From the home page, you can go into the calculate menu in the scratch pad or via a document. So I'll just use the calculate menu from the scratch pad, and what I want to select is from the menu I want to go into the algebra down to number 7, solve a system of equations, and what I want is a system of linear equations. I have two equations with two variables x and y, so I'm going to select OK. What I need to do now is type in my two equations. So using the grade buttons at the bottom, which are programmed as variables, I'm going to type in x plus y is equal to 2x minus 3. That's my first equation. The second equation, 2x is equal to 5y. Hit enter, and here we have our solutions, and our solutions are x equal to 5 and y equal to 2. So our solutions, x equal to 5, y equal to 2, and then of course, depending on whether the question asked you to find the length of the diagonal or indeed one of the pieces of the diagonal, you would substitute those values back in order to find the respective lengths if required. Okay, so we'll move to the second example now. Once again, we have a parallelogram ABCD based on the markings of both pairs of opposite sides parallel. Once again, we should know from the properties that the opposite sides of a parallelogram are congruent in length, and so we would quite easily be able to establish an equation. In this case, 2x plus 4, the length of side BC, is equal to x squared minus 11, the length of side AD. Once again, I'm interested in the solution to this, so I want to solve for x, so I'll come back to the calculator. Once again, if you're in the scratch pad, that's fine. We'll go to menu, we'll go to algebra, and what I'm interested in this time is the solve function. I'm going to enter the equation 2x plus 4 is equal to x squared minus 11, and what is required in the solve function is that you use the comma and then type in x, and that is so the calculator is knows to solve for x because that is the variable in the equation. Hit enter. The calculator will produce the two answers for me. X is equal to minus 3 or 5, and what you would need to do in this case, ordinarily if we were looking for the lengths, you would have to substitute back, but we do need to be cautious. There are instances in which one of those two solutions would be extraneous, which means if we sub them back in, they produce a result which is not acceptable, for instance a negative length. Now, it's not necessarily true that a negative value will produce the negative length. It could be that the positive value would, and so we're going to do a quick check. If we sub 5 back in there, we get 2 times 5 is 10, plus 4 would give us a length of 14. X squared, which would be 5 squared, is 25 minus 11, which would give us 14, and so we know that the 5 works. If we substitute with minus 3 in. However, 2 times minus 3 is negative 6. Negative 6 plus 4 produces a length for BC of minus 2, and that of course is unacceptable. So in this case, the negative did produce an acceptable answer, but that won't always be the case. You do need to check both of your solutions for the quadratic by subbing back in.